work again. So you guys, your code was the fix for their bug. Okay, so that's all I'm going to say about Windows and Android. But we found similar bugs in other phones. I just like the iPhone one because I actually wrote the exploit. Okay, so anyway, so I needed to generate these test cases. I use Sulley, which is a fuzzing framework written in Python. It does lots of stuff. It generates test cases. It sends test cases. It monitors. It does postmortem analysis. But I only use it for test cases because I have code to do all the rest of that stuff. It uses a block-based approach, like you might have heard talk about in fuzzing and spike and all that stuff. But basically, it comes with a library full of things that have been found successful in the past. So, for example, it had a %n in one of its fields. So it's like way better than Spike, and if you've heard of Peach, it's like Peach, except no one maintains Sulley anymore, and they still maintain Peach. And I just use Sulley because that's what I learned on. Okay, so what does Sulley look like? So you basically just have to describe what data looks like, and it'll generate a bunch of test cases for you. So remember back when I showed you what SMSC number looked like, it looked like this. And this is how I would describe in Python what this looks like to the fuzzer, and then the fuzzer could generate me a bunch of test cases. So you say, okay, well, first there's a size. And the format is oct, which means it's supposed to look like, 0 through 9 and A through F, right? That's how those PDUs look. I had to write that because, no other protocol really uses this. And then you say, oh, and then, the math is really divide by 2 because there's twice as many or something. Okay, and then, so then there's a block. So this is the thing I'm supposed to find the length of. So then I have a byte, that's the type, and then I have a string that is supposed to be encoded. So that's what I call this 8-bit encoder. And that's it. So you just you give this much Python to Sulley, and you say go, and it'll generate like a ton of invalid SMSC numbers. Likewise, if you want to see what UDH looks like, it's just a little more complicated, and you can look, and there's there's 2 sizes, right? There's UDHL and a IEDL, and you'll see those in there and so forth. But basically the point is you don't have to write too much Python to describe this, and then you can quickly get like millions of test cases. Yeah. But what do you do with the test cases, right? So I could literally just send them all like 100,000 or a million from one phone to another, but I don't have an unlimited SMS plan, and even if I did, eventually they are going to kick me off. The other thing is I don't want the telcos to watch me fuzz, because then they get all my test cases. And this is my own stuff, so I don't want them to know what I'm up to. And the other thing is their equipment is handling these text messages going from my phone to the other phone, and eventually I'm fuzzing their stuff too, and I don't want to fuzz their stuff because I don't want to go to jail. So the other thing you could so I don't want to send it over the air. I could build my own radio, but that sounds way too hard to me. I just I like writing Python. That's about it. So. What else can I do? Okay, well, I could actually, inject it into the actual process, which is, I was talking to some mobile guys here, and that's what you guys, I guess, do. But for me, that's not good, because I want to do iPhone, Android, and I want to do Windows Mobile. So it would be too dependent on the firmware. And so I just did SMS injection between the 2 processors. So I basically do a man in the middle between the application processor and the modem. And so at least with GSM, they have a serial line. They do these at commands, and it's very easy to just to do that. So I basically do library preloading, and when it tries to open up or read or write to this virtual serial line, I just get in the middle of that, and I also open a TCP port. And so I'll if regular SMS messages are going on, I just ferry those back and forth, and when it gets something on the TCP port, I put that in, and it can't tell the difference that this came from me versus the real network. Like I said, so the great thing is I can hammer, as fast as I can send TCP packets, I can send SMS messages. Doesn't cost any money. Don't have to buy any equipment. I don't have to know jack about radios or how they work. The receiving process can't tell that they didn't come over the actual radio. For the most part, the telco company doesn't know I'm up to anything. And the one thing you have to watch out for, though, is if you find a crash doing this, it's not really legitimate until I've actually sent it over the network. So sometimes we would find crashes that would work this way when I inject it. When I actually try to send it over the real network to another phone, the AT&T or somebody would have filtered it, and so it never got there. So you have to verify everything still works. Yeah. And then here's the actual code you can do to set up the library preloading. And then the Python you need at this point to just send the PDU is real easy. You just send it. Done. Okay, so that's everything you need to know up to this point. Now let's talk about the bug I found and how I exploited it, and you'll see how the work you had to do this. So like I said, the first thing I had to do was make sure that this bug was legit, that you could send it over the network, and you could. It turns out almost all the ones we found you could send over the network, so the carriers don't do a whole lot of filtering. So then we built a small application that would actually, by sending GSM AT commands, would send the thing. And it turns out that the interesting thing was different carriers filtered different things. So there were sometimes, Colin was in Germany, sometimes his carrier would allow him to send one to me, but like I couldn't send it to him because AT&T would filter it or something. So it was sort of interesting. You had to try different things. It turned out the one that was really serious, everyone let go. And here's what it is. So this is what the crash looked like. So you're fuzzing, and then you start to get things like this, and you're like, cool, I found something. And when I talked to BlueHat, this was when 3.0 was out. It hadn't been fixed. But the next day, they fixed it. I had reported it like a month earlier, like a good guy. And so they fixed it the next day, and that's why 3.01 was released, was because of this bug I'm about to show you. Oh yeah, so this is my Terminator quote. Like every talk I give has Terminator quote in it. So this white thing is actually the bug. So the bug, in its most simple form, is represented by this: 04, 00, 03, and then any 2 bytes you want. So that's how simple this bug is, but it's pretty bad. And the point of the quote is that, okay, so if I can send you an SMS message and take over your phone, like this is like Blaster for phones, right? So then I read your contacts, and since iPhone people are all a bunch of Apple geeks, all their friends are probably Apple geeks too. So I can just send out SMS messages to all the phone numbers they know, and then all the phone numbers they know, and so you can basically take over all the iPhones in the world in a couple hours. So it's pretty cool. All right, unless you're Apple. So let's take a look at this bug. So the bug is there's a function that I call for them, read next byte. And what it does is it's reading bytes off of the SMS message, the PDU that you sent it. And it returns 1 byte, the next byte, obviously, unless there's an error. So if maybe it runs out of bytes to read, instead of returning the next byte, since there is no next byte, it returns -1 to indicate an error. So if you look through it, says, okay, remember those 3 bytes for concatenated messages? It reads the reference number, the total number of messages, and then what message number this is. So that's exactly what this code does. What could go wrong, right? Well, it turns out that the bad thing is if you don't send in enough data, get next byte starts returning -1, but they never actually check that this error could occur. And so it starts thinking that these -1s are valid numbers. And so you can make this message number be -1, or you can make the total number of messages be -1. So there's lots of weird things that can happen. Or this is just the field I happened to pick, which was concatenated messages. But you can do this for any of the fields. All right, so this is bad that they do this. And the reason is the following. So this is actually, on the bottom, is a PDU that you could send to someone who hasn't updated their iPhone, and I think it crashes their phone. So actually, so it crashes CommCenter, which is the process that handles SMS and their phone. So it'll knock their phone off the network for, and for as long as it takes the process to restart, which is like 5 seconds. And here's another funny story. Well, funny for me. So at BlueHat, I was going to, well, I won't say that part. So at BlueHat, I wanted to do a demo, right, to show that this was legit. And so I found someone at the last second who worked for some carrier somewhere. And he said, oh, you can use my phone. So we started sending so the idea was, okay, well, I can knock you off the network for 5 seconds with an SMS message. What happens if I send one every 5 seconds, right? So I started sending him the SMS messages every 5 seconds or whatever it was. And then, like, as a demo, I tried calling his phone, and sure enough, like, he couldn't pick it up, right? It just went straight to voicemail. It was like, oh, this is a great demo, okay, whatever. So then, of course, I turned the thing off at the end of the talk to put him back on the network. And one of the great things about SMS messages is that if you're not on the network and someone sends you an SMS message, the carrier queues those up for you. So the next time you turn on your phone, it's like, oh, hey, while you were gone, here's a couple of text messages that someone sent you. So I didn't know anything was wrong, but like 3 hours later, he comes up to Colin, the guy I gave the talk with. He's like, hey, Colin, when are you guys going to turn off the attack? And I was like, oops. So apparently, like, we were sending them slightly faster than his phone was restarting, and so the AT&T or whoever had queued up like thousands of these malicious SMS messages, and they just kept sending and sending and sending. So he couldn't be on the network for hours, and eventually, they all got there, and everything was great, but it was pretty funny. Anyway, so what happens with this bug? So if you can read this code, what happens